Kia ora. So this is the second of the talking over PowerPoints videos that I've made for time series. So today we're looking at the analysis with the long-term trend. So here we go. So the long-term trend is put over the top of a graph so that we can see what's happening over the whole period of time that the graph is drawn for. So this graph shows the raw data. It goes up and down all over the show, the Arctic sea ice graph. And we want to work out the long-term trend. By hand, we would have fitted a line of best fit. So we would have perhaps said, okay, sort of halfway through, it kind of goes like this, halfway through. And we can see that it's got a downward slope to it. So we'd be talking about it decreasing. And before we had technology, in order to get rid of all these bumps, we would have calculated what's called a moving mean. So we would have perhaps found the mean of 4 or 5 values and plotted that in the middle, and then we would have dropped one and picked up the next one, and that would flatten the graph out and give us a good idea of what's happening over the graph. Another way you can do it is to look at the top. So basically try and get close to the tops and close to the bottoms and look at what's happening. Is it happening the same in both? But now, of course, we can use technology. So using NCEA Grapher, we can import the data. So I'm going to show you how to do that. So I'm looking at the sea ice data. So we put it into NCEA Grapher. And I give acknowledgement to Jake Wills for providing us with this wonderful tool. And I'm looking at time series. So I have to go right down here to time series, the first graph of 4. So our variables are going to be always time along the bottom because it's a time series graph, always have some sort of time along the bottom. And our second variable, we're looking at the Arctic data. So there's my graph. All right, now I have to do all the things like usual, so improve the graph title, so sea ice or Arctic, sea ice from 1990 to 2020 or something like that. Change the date along here, so 1990 to 2020 as well, and a little bit more explanation of this one. Arctic sea ice measured in square kilometers, I think. Okay, so not very well spelt there, but that's all right. Update your graph so that everything is on it like this. Okay, and that's our first graph we put in because that's our original data and that was what we would talk about. Okay, the second thing we want to do is we want to put in a long-term trend. So by putting this in, the graph will, we don't need the seasonal effects at the moment, so take that one off. The long-term trend will work over the top. Now you can see this is a wriggly line because it's been averaged out as we go across the graph, and you can follow it and actually see what the values are along it. All right, but we do want the start and end points. They're part of what we need as far as talking about it. So you can see an 11.7 turned up there and a 10.4 turned up here. So that's the graph we are going to right-click and copy into our assessment. Okay. So now that we've done that, these are all the buttons we need to choose. So you can see I've changed the heading and the dates and the axis here, put the 2 ticks on that I wanted, and updated the graph. So this is the time series first graph, graph 1. So copy and paste it into your assignment. Don't make it tiddly-widdly so the person marking your assignment can't see it. Try and make it fit the width of the page. So pull it out to fit the width of the page so that we can actually read on it what your values are and things like that. What can you see happening overall to the black line? So when we draw a graph, we always talk about it. We never put a graph in any sort of assessment without talking about it. So this particular graph, we need to talk about what we can see happening to the black line. So remember to give specifics, dates and values, and use words like monthly, You use the endpoints to calculate the gradient. So we want to talk about the average change over the period of the graph. Look for significant changes in the trend and try and account for them. Common ones are earthquakes, global financial crisis, SARS, and obviously now COVID. So we would add COVID to that list. So here's my example for Arctic sea ice. I've put my graph in, and if this was on paper, that would be the full width of the page, but I need to be able to write other things around it. So explaining what's happening on the graph shows that overall, the amount of Arctic sea ice has decreased from a monthly average of 11.7 million square kilometres in January of 1990 to a monthly average of 10.4 million square kilometres in April of 2022. This is a decrease of 1.3 square kilometres on average, or an average of 43,333 square kilometres per year. Okay. There seems to be a significant dip around 1996, and I could talk about the fact that there looks like there could be one in 2007, but I don't want to go over the top because obviously I want to be able to talk about things that are happening on the graph throughout my investigation. But I have investigated that serious dip in 1996. So I went back to an article and found out that there was high sea ice extent event in 1996. This was associated with persistent low pressure over the central Arctic, coupled with high pressure over the eastern Arctic coasts, which generated anomalous northerly winds and resulted in negative anomalies of above-mentioned atmospheric parameters. So I'm thinking that had something to do with that dip. All right, so I'd like you to continue with your visitors one and try and put those two sections in. Have a go.